everyone. So in this video, we are going to be taking a look at some basic questions involving average, essentially just getting comfortable with the concept of average as it pertains to your S.E.A examination. Now, what is average? Well, the definition of average is that it is a measure of central tendency. Now, that sounds like a very big, fancy definition, but essentially what it means is that once we take the average of a set of numbers, we expect all of the numbers in that set to be around the value of the average that we actually find. Now, that is not always the case. The average is not always the most accurate measure of central tendency. However, it tends to get more accurate the more numbers we actually have in that set, right? So if we have 5 numbers, we might get a less accurate answer than if we have 500 numbers, okay? And you will see what I mean as we look at some examples in today's video. Okay, so without further ado, let's just get into the video and we'll look at the questions. Question 1. Find the average of the following numbers. We have this set of numbers 3, 7, 8, 9, 6, and 3. How do we find the average of these numbers? Now the average, the formula for average, that would be the sum of the numbers divided by the number of numbers. Okay, so that means what we need to do is add all of the values in our set and then divide by how many values are in our set. So let's find the total first, or the sum, right? They are synonyms. So 3 plus 7 plus 8 plus 9 plus 6 plus 3. 3 plus 7 is 10, 10 plus 8 is 18, 18 plus 9 is 27, 27 plus 6 is 33, and 33 plus 3 is 36. Okay, so the total is 36. So we'll put 36 as our sum, divided by how many numbers are in our set? 1, 2, 3, 4, 5, 6. So 36 divided by 6, which is 6. So our average, right, our answer is 6. Our average is 6. Now let's look closer at our data set. Remember, I said that average was a measure of central tendency. So we should expect the values in this set to be around 6. We have one value that's 6. We have a few values that are sort of close to 6, so 7 and 8. 9 differs from 6 by 3, and so does 3, right? So some of these values are fairly close to 6, but let's actually look at an example where we only have 2 numbers in our data set as opposed to 6 numbers. Let's take, for example, 10 and 2. Right now, when we add 10 plus 2, we get 12. And there's 2 numbers in the set, so the average would be 12 divided by 2, which is 6. Right? So we get the same average, but we have a different number of numbers. Okay, we have 2 numbers instead of 6 numbers. And as you can see, 10 and 2 are very different from our average. It's very different from 6, right? They are further apart than any of these values from 6. So that's why I say as the number of numbers increases in your set of numbers, right, usually called the data set, your average will get more accurate as it pertains to the definition of average, which is a measure of central tendency, right? And that is something that is noteworthy. So now that we know how to find average, let us move on to question 2. Question 2 says, the average number of marbles among 6 boys is 17. What is the sum of all the marbles of the 6 boys? So let me just remind you of the average formula, and then I will introduce how to find the sum. So we know that the average is the sum of numbers divided by the number of numbers. And we also know that the definition of sum means you have to add up all the numbers. But what if there was another way to find the sum of numbers? What if I told you you just need the average and you just need the number of numbers in your set? Okay? And you can clearly see how we can find that from this formula for average. Because if the average is the sum of numbers divided by the number of numbers, then that means, let's just do a little rearranging here. So let's take the sum. Right, the sum of numbers is going to be equal to the average multiplied by the number of numbers. That's just basic multiplication and division linkages. So if the average is the sum divided by the number of numbers, then the sum of numbers will be the average multiplied by the number of numbers. And this is very useful, as you will see in the following questions. But let's just practice finding the sum. We know that the average is 17, right? So don't get mixed up with that. It says the average number of marbles among 6 boys is 17. So the average is 17. And the number of numbers is 6. So the sum will be 17 multiplied by 6. And let's work that out here. 7 times 6 is 42. 1 times 6 is 6. And 4 is 10. So the sum is 102 marbles. Right? So how do we interpret that? Well, if we did have the individual number of marbles of each boy and we added it up, we would get 102 marbles. But this is just a quicker way, right, which uses the link between average and sum so that we don't actually need to know how many marbles each individual boy has, right? But it can be very useful in determining how many marbles or how many items or whatever else your data set is describing. It can be useful in figuring out what one particular person or thing has in that set. And as I said, you will see that in the later questions. So let's move on now that we know how to find the sum. Once again, question 3. A cricket team's average number of runs in 4 matches is 64. What is the total number of runs in all 4 matches? Now, again, sum is another synonym for total. So the total, of course, will be the average multiplied by the number of numbers. In this case, the number of numbers would be the number of matches. So we know the average is 64 and the number of matches or the number of numbers would be 4, right? So the cricket team would have 4 individual run scores, and if you add it up, you will get the same answer as if you were to do 64 multiplied by 4, which is what we are going to do now. So 4 times 4 is 16, carry the 1. Then we have 6 times 4, which is 24, plus 1, which is 25. So we end up with 256 runs in total. And that's your answer. Right, so our answer, 256 runs. And you have to answer the way the question asks, what the question asks for, right? So the number of runs, we answer in runs. Okay, let's move on. Question 4 says, Kimberly and Jared have an average of 8 stickers. If Jared has 10 stickers, how many stickers does Kimberly have? So this is where we actually see the power of average and what we can do with it. We don't know Kimberly's number. We don't know how many they have altogether, but we do know their average, and we know Jared has 10 stickers. Right, now let's break down that first sentence. Kimberly and Jared have an average of 8 stickers. We know that if we add Kimberly's number of stickers and Jared's number of stickers and divide by the number of numbers, which in this case is 2 because they're 2 people, then that answer is going to be 8 because that is our average. So if we know the average and we know the number of numbers, what can we find? We can actually find the sum of Kimberly's and Jared's stickers, right? So the sum would be the same formula from before, the average multiplied by the number of numbers. And that's going to be 8 multiplied by 2 because we have 2 people, which is 16 from our times tables. Now, this sum is the same as the total of their numbers. So if we add Kimberly's number and we add Jared's number, we will get 16. But what do we know about Jared? We know that Jared has 10 stickers. So that means that Jared plus Kimberly is equal to 16. But we also know that Jared has 10, so 10 plus Kimberly is equal to 16, right? And Kimberly will have 16 minus 10, which is equal to 6 stickers. So my answer for Kimberly's number of stickers is 6 stickers. So we just found Kimberly's number, knowing just Jared's number and their average. We found the sum from using the average and the number of people or the number of numbers. And then we did a simple subtraction because that is the definition of sum, right? It's the total number of their stickers. So Jared plus Kimberly would have been equal to 16. Jared was 10. So we just took away 10 from 16. And we got Kimberly's number, which is 6 stickers. So this is what average can be used for. And this is just a very simple example with 2 people. It gets a lot more interesting when we look at more people. So let's look at an example with 3 people for question 5, and then it gets a lot more interesting in part 2 of the average series. Okay, part 5 says, Michael, Jordan, and Taylor picked an average of 18 mangoes. Michael and Taylor each picked 20 mangoes. So how many mangoes did Jordan pick? Again, we can go ahead and find the total of Michael, Jordan, and Taylor. In this case, we have 3 people and their average is 18. So the sum is going to be, again, the average by the number of numbers, which is 18 multiplied by 3. Okay, if you need to work this out on the side, you can, but the answer here is 54. So altogether, Michael, Jordan, and Taylor have picked 54 mangoes. So if you add up Michael's amount, Michael's number, Jordan's number, Taylor's number, you will get 54. So Michael plus Jordan plus Taylor is equal to 54. What do we know about Michael and Taylor though? We know that Michael and Taylor each picked 20 mangoes. So Michael plus Jordan plus Taylor, so that's 20 plus Jordan plus 20 is equal to 54. Now 20 plus 20 is 40. So Jordan plus 40 should be equal to 54. Right, so simple. How do we find Jordan's amount? that would be 54 minus 40, right? And that gives us 14 mangoes. So we know that Jordan had to have picked 14 mangoes. And you can always check this over by adding 14, 20, and 20 and dividing it by 3. You'll get back your average of 18 mangoes, right? So Jordan picked 14 mangoes. And that is the end of part 1 of average. In part 2, we will look at a bit more involved questions where we have some more steps and we see some more complex uses of average. So I will see you all in the next one.